Today we're going to look at Azure Virtual Networking. We're going to look at the basic starting points for virtual networking and what you're going to need to know to really start to throw up a few virtual machines and get them to talk to each other, and also maybe talk to those virtual machines from the outside world. So let's go and have a look very quickly at a diagram of what I'm going to attempt to build for you today and attempt to show you how it actually functions today. Right, so let's go have a look at Azure Virtual Machine Networking and the things that we need to know to start off with. So our basic unit of networking in Azure, if we want thing A to talk to thing B, is to actually go and create something called a VNet. Now, if you look at the other clouds, if you look at things like GCP and you look at things like AWS, they have the concept of VPCs, or virtual private clouds. It's not really a direct translation, but I think it's probably pretty similar to say that a VNet is a bit like that. So with our VNet, if we go and build a brand new VNet inside our environment, one of the things that we need to do first is to actually assign an IP address range for that VNet, or a selection of IP addresses that can operate within that VNet. We can actually have multiple IP address ranges, but for my demo here, I'm actually going to be pretty quick and easy on this one and use 10.0.0.0/8. So this is CIDR notation, or classless interdomain routing. Azure uses CIDR notation here to spec out ranges of IP addresses in most of the wizards. Not all of them, but most of the wizards. Don't ever expect any consistency in Azure wizardry. Now, within a VNet, you can't actually go and use this to start with. You're going to have to create a couple of things inside here. Inside this VNet, you're going to need to create a couple of subnets. You need at least one subnet. If I have, for example, here subnet 1 and subnet 2 inside my environment, these subnets need to have an IP address range that is actually a subselection of this main IP address range here. So for subnet 1, we might give this something like 10.10.0.0/16, and for subnet 2, we might do 10.20.0.0/16. Once we have these two subnets created, what we can actually do is we can start to attach things to them. So what I'm going to do is I'm going to attach a couple of virtual machines to these. I'm going to create a VM1. And remember, when you create a virtual machine in Azure, there's a number of things you actually need to select with it, and a number of components that actually come with it. You can actually go and see that from my previous video at creating Azure virtual machines. Now, one of the things this virtual machine actually gets is its own VNIC. Now, the virtual network card for the virtual machine is a separate object inside Azure. It can be a little confusing the first time you see it. It's the VNIC that actually attaches to the subnets, not the virtual machine itself. You can actually destroy a whole virtual machine and rebuild it without actually changing the VNIC. This VNIC is also where the IP addresses will be assigned to. So these are going to be servers, and they're going to use dynamically assigned IP addresses. The dynamic assignment is going to come from the Azure Virtual Networking structure down here. Now, if you're used to on-site systems, you might be looking at attaching static addresses to servers, and that's perfectly fine to do. But in Azure land, it's generally better to go and use dynamic assignment of addresses to virtual machines. We can cover that, why that is, later. The next sort of question that normally comes up at that point, though, is, can I use a static address? Yes, you can. I'll go over that later on. Okay? So, what will happen is, once this virtual machine is attached to this subnet, it will receive an IP address. In fact, it will end up receiving an IP address of 10.10.0.4. In fact, numbers 1 to 3 are actually reserved internally for Azure Gateway Services. And it will see that dynamically, and the IP address is received by the NIC, not by the VM. The NIC will then actually inject that IP address into that virtual machine itself. So that means if you delete and rebuild the virtual machine, you'll still end up with the same IP address, which is nice. Also, because this is a demo, what I'm also going to do is on this virtual NIC, I'm going to have a public IP address actually attached to it as well. This public IP address is connected directly out to the internet, and this will allow me to actually go in and RDP to this machine directly over the internet. Now, in the real world, that's a very, very, very bad idea. This is a demo, this is a lab, okay? This is just a demonstration. It's a very quick and easy way of doing things. In reality, there's way better ways of connecting to a virtual machine over the internet that's much more secure. One of those I'll be covering in a future video that's actually called Bastion server. A way better way of actually accomplishing this. The second thing we're going to do is we're going to set up a second virtual machine. And we'll create another VM over here, call it VM2. This will also have an appropriate VNet attached to it over here, which will be attached to subnet 2. This will end up receiving another IP address of 10.20.0.4. We'll receive an IP address from the range that's attached to that subnet. What we're then going to be able to do is we're going to be able to look at one of these virtual machines like VM1 and be able to establish that we can actually do communication between VM1 and VM2. That's because inside these VNets, even though we've got separate subnets, there is a routing capability inside the VNet itself that will allow us to automatically route between any of the amount of subnets that we create inside that VNet. We're also going to have a look at the IP addressing structure inside one of these virtual machines to see what it kind of looks like on the operating system level and some of the pitfalls that we might fall into when we're configuring this inside our live environments. So let's go over to the resource group section inside my Azure portal. And in this portal, we're going to do our usual thing. We'll create a new resource group and we'll call this VNet demo. And we'll put this into UK South. Again, there's no rhyme or reason to the reason why I do UK South. It's just that I know that these demos will actually work in them. There are some very subtle differences between the different Azure regions. I just know that these demos work in UK South. So what I'm going to do is I'm going to look for virtual network in here. We're going to virtual networks. We'll create a new VNet. Now there's lots and lots and lots of settings. Just like everything else in Azure, there is a lot of documentation on every individual thing we do. So we're going to call this VNet1, again UK South, and I'm going to change this IP address space to match up with the diagram. So this is going to be 10.0.0.0/8, and we're going to add a couple of subnets in here. I'm going to call this sub1 with 10.10.0.0/16, and we're going to add another subnet here called sub2 of 10.20.0.0/16. Now I can use whatever IP address ranges there I actually wanted, but I'm keeping it simple within this format just by using 10.10 and 10.20. So I'm matching up with exactly what we've got drawn out here within our VNet configuration. So let's go next on that one. I'm not going to actually deploy, in this sense, Bastion host, a firewall, or some DDoS protection standard, but I will come back to these at a later date, especially Bastion host, as it's an incredibly useful thing. Hopefully, you'll be able to see very shortly a link to that video. Somewhere around here, I'll put it in as soon as I've built it. I'm not going to tag this resource, even though I probably would do in a live environment, and I'm going to create it. Now, we'll leave that to actually build and go and have a look at it once it's constructed. So we can see here our Azure Vnet is constructed, is nicely built. We have an address space of 10.0.0.0/8, and we have nothing else actually turned on here. We have none of the DDoS protection or private endpoints or peerings or anything else. We'll cover some of these at a later date in another video. We can see my address space is 10.0.0.0/8, and my subnets are subnet 1 and subnet 2 of 10.0.0.16 and 10.20.0.0.16. Perfect. Now let's get over to creating virtual machines. So if we go into virtual machines here, I'm going to build a couple of virtual machines. I'm going to create some standard machines, one called VM1 and one called VM2. So let's go to our resource groups and our VNet demo, and let's create VM1 here, and let's go and change that from Ubuntu to Windows Server 2022, the Azure Edition Gen 2 here. We're not going to do anything particularly special with these machines. They're just going to be pretty standard machines. and they are going to be running on standard DS2 v3s. This inbound port section down here, this will actually make sure that RDP is allowed through the network security group that's attached to this VNet. I'm going to tell Microsoft that I already have a license, so this is going to be slightly cheaper for me to run. And I'm going to make sure that on the networks, I'm connecting VM1 to subnet 1 inside VNet 1 here. It's going to create a public IP address for me called VM1 IP as well, which is all nice. I'm not going to bother creating any boot diagnostic systems here. That's just going to overcomplicate what we're doing for the moment. If we go and create this, we can leave that to build. And while this virtual machine 1 is actually building, we can go back and we can go into virtual machines and we can build another virtual machine called VM2. Now, admittedly, if you were building a lot of virtual machines in Azure, you could go and build these with things like templates, or with existing images, or with Terraform, or with command line, or anything else that you see fit to deploy multiple things multiple times. I'm just using the simplistic method here. Notice this VM2 is going to subnet 2, not to subnet 1. But I'm just using the simple methods here of building this through the wizard. It's quick and easy enough for me. So we'll leave that for a moment to actually construct. And once that is constructed, what we should have is we should have a representation of this diagram here. We should have a VM1, which is nicely built and constructed and attached to subnet 1, and we should have a VM2, which is nicely built and constructed attached to subnet 2. And then I am going to attempt to RDP directly to VM1. Okay, so we now have built out here inside my VNet demo resource group a few resources. We have a VM1, a VM2, and we also have a VNet called VNet1. If we click on the resource visualizer here on the left hand side, we can get some kind of visualization of what's going on in here. It's not particularly brilliant, but it kind of works. We can see that we've actually got both our VM1 and our VM2 here attached to specific NICs, and these NICs are actually attached to VNet1. Okay, that's wonderful. So if we come in here and have a look at VNet1, you will be able to see inside VNet1 and have a look inside our connected devices section, these two connected devices. Notice it doesn't say VM1, VM2. It's actually got the names of the virtual machines NICs, not the VMs themselves. But you'll notice the IP addresses attached to them, 10.10.04 and 10.20.04. Now, if I drop in here, back to VNet demo, and go back to VM1, if I go and connect to this VM1, remember I have a public IP address attached to it for these purposes, I can just download the RDP file, open that thing up, connect into it, and I will connect in with the username and password that I created when I first built the VM. So this is currently loading in. It's loading in as MicAdmin. And you'll see it's just a VM. There's nothing particularly special running inside here. It's starting for the first time, so it's taking a moment just to get going. While that's doing its thing, what I will do is I will drop back into VM2 and I'll do the same connection to VM2. So let's download that RDP file, open that up, and connect to VM2. Let's do a MicAdmin. Connect into that. Wonderful. So I now have a VM1 and a VM2 remotely connected here. Let's go and have a look a little bit at the internal workings of this. Okay, so I have Windows Server 2022 running here. Let's go and run a very quick IP config once it loads and actually see what the IP addresses look like. just by bashing up command prompt here. We'll do an ipconfig/all, and we can see a little bit of information. Notice this thing has a hostname of VM1. It has a DNS suffix search list of something rather random. Because we haven't done anything with DNS yet, what Azure's done is it's given us a unique address. What you'll also see down here is the IPv4 address is 10.10.04 preferred, because it looks like DHCP to this system. You'll also notice the default gateway is 10.10.01, which allows this thing access out to the internet, because by default this VM is going out to the internet as well. We've got the DHCP server and the DNS server looking like this very strange IP address here though, 168.63.129.16. It looks like a public address, and well, it kind of is. But it's an internal Azure management address that's providing DNS and DHCP services to this server. Do not block that IP. If you block that IP, you're going to have a bad time. And this thing's going to drop off and stop working. So if we come down here, go to CMD. Drop into a command prompt on VM2. Let's do the same thing, ipconfig/all. What you'll see is again, I have VM2 here, and I have 10.20.04, okay? Different range because it's come from a different subnet. Now, let's see if we've got communication between the two. So what about if I do ping 10.20.0.4? What happens? Nothing. This doesn't necessarily mean that communication is failing between these two. It just means that ping is actually blocked. And it's actually blocked because of the internal firewall on Windows. We can prove connection in a number of different ways, but one of the easiest ways we could prove connections is to bounce up MSTSC here and bounce up a remote desktop connection. So now what we're essentially going to try and do is we're going to take these two machines here, VM1 and VM2, and we're going to run an RDP connection between them. Because we know that port 3389, the RDP port, is open. How do we know that? Well, we're RDP to it already. So let's just try going to 10.20.0.4, hit connect, and we should get a connection dialog box pop up. There we go. So now if I type in micadmin and attempt to log in again, this connection over here is going to die because it's going to get rerouted inside this connection. Give that a moment and you should see. There we go. Connection has died and connection has rerouted inside here. We have control of VM2 inside VM1. So because of that, we are proving that there is actually communication between those two networks. And because we're proving there's communication between those two networks, we know that there is automatic routing between these two subnets. So just to summarize, when we go and create an Azure Virtual Network, to make use of that Azure Virtual Network, we need to build subnets inside that virtual network. And when we attach resources, like, for example, virtual machines to those subnets, you need VNets that actually get attached to those virtual machines. I just want to cover one final thing inside here before we finish this video off. What about if we wanted a static IP for our virtual machines? Because yes, technically that virtual machine's IP address could change. Well, the only way that you can do it is through the Azure portal. If you take the traditional method, say for example, you came here into a server and you had a look for network and sharing center. Let's go into view network computers devices here and get to it from there. Open network and sharing center, there we go, because why would I expect search to work in Windows Server? So let's go into network and sharing center and view hardware and connection properties. Where are we? It's not what I want. I want change adapter options, finally. Okay, so what about if we go to the traditional method of doing that? What about if we go into a network connection, go to properties, go to TCP/IPv4, go to properties and change this to give it a static IP address. It's very easy to do, and it will let you do it. You'll break it. You do that, you will break the connection to this VM, and you will have to reset the networking for the virtual machine outside it. Not going to work. The way that you actually set a static IP address is you have to come in here, find the network interface that's connected to that virtual machine. So in this case, this one is connected to VM1. I have to drop into IP configurations. I have to drop into IP config here. And what I actually have to do is change this assignment from dynamic to static. This is not technically a static IP address. Technically, it's just telling the software-defined networking system of Azure to use that same address over and over again. You could think of it a little bit like a IP address reservation in DHCP more than anything else. But that will mean you have a static IP address then attached to that virtual machine if you want it to never ever change. So that brings up a conclusion for our Azure Virtual Networking section. There is a lot more to go through with Azure Virtual Networking. We will expand this out later on with Azure Networking Peering. We will have a talk about express routes, and we'll have a talk about VPNs in the future. And we'll also talk about very important remote access methods that are secure, like Bastion Server. We'll also work on in the future into getting other clouds to talk to Azure, and we'll look at Azure Arc, and we'll see how we can get virtual machines that live in Oracle Cloud, and virtual machines that exist in GCP, and virtual machines that exist in AWS, all to be interconnected with the networking stacks inside Azure so they can all talk to each other, even though they're in different clouds, in different data centers, in different parts of the world. It's very exciting stuff, the hybrid cloud. You use what you want to use from whatever company you want to use, but you can use Azure to manage it. Genius solution from Microsoft. I'll see you next time.